Hello everyone, this is Kenji Fujii from Chiba Institute of Technology speaking. This time I would like to make a presentation entitled Prediction of Peak Response of Irregular Base Isolated Building Under Pulse-like Earthquakes. When we conduct seismic assessment of an asymmetric building, it is essential to carry out three-dimensional analysis considering all the possible directions of seismic input. For this purpose, we have proposed a simplified procedure, that is, mode-adaptive bidirectional pushover analysis. In this procedure, the upper bound of peak response of an asymmetric building under bidirectional seismic input is predicted by considering the two independent equivalent single degree of freedom model. This procedure has been extended for an irregular base isolated building. It is well recognized that the near-fault pulse-like ground motions have large directivity effect. Therefore, the response of building may be influenced significantly by the angle of seismic incidence. In addition, the pulse period Tp would be longer when the moment magnitude becomes larger. Therefore, the following questions arise. How accurate is the updated mode adaptive bidirectional pushover analysis for a base isolated building subjected to pulse-like ground motions? The second question is, does the accuracy of the updated mode adaptive bidirectional pushover analysis depend on the pulse period of ground motions? So, in this presentation, the accuracy of the updated mode adaptive bidirectional pushover analysis is investigated considering pulse-like ground motions. I would like to explain about the updated mode adaptive bidirectional pushover analysis. There are two updated points in this procedure. That is, bidirectional momentary input energy is implemented into this procedure as a seismic intensity parameter. The second is the peak response of each mode is predicted from the energy balance in a half cycle of structural response. This figure explains how to predict the peak response of each mode. The increment of hysteresis dissipated energy in a half cycle is calculated considering the hysteresis loop. The maximum momentary input energy in a half cycle is calculated from the bidirectional V delta E spectrum. Considering the energy balance in a half cycle, we can obtain the peak equivalent displacement of each mode. The other part is the same as the original procedure. I would like to explain the building model. Here shows the structural plan and overview of the base isolated building model. This is a 5-story base isolated building model. As you see, the superstructure is quite irregular in plan and also elevation. Isolation layer is installed below level Z0. Next, I would like to explain the ground motion data and analysis method. In this study, 45 ground motion sets from NGA West 2 ground motion database are used. These ground motion sets are divided into three groups based on the pulse period Tp proposed by Baker. The range of Tp for group 1 is from 1.0 seconds to 2.0 seconds, while for group 2, the range is from 2.0 seconds to 4.0 seconds, and in group 3, Tp is larger than 4 seconds. Those ground motion sets are scaled according to the bidirectional V delta E spectrum. The angle of seismic incidence ASI is set in the range of minus 75 degree to plus 90 degree with an interval of 15 degree. In this presentation, the response parameter of nonlinear time history analysis is taken as the largest value among the nonlinear time history analysis results for all ASI. I would like to discuss the accuracy of this procedure. Here shows the accuracy of the predicted equivalent displacement of the first and second model responses. The horizontal axis indicates the accuracy ratio of the response parameters obtained from the predicted by the updated procedure and the nonlinear time history analysis results, while vertical axis indicates the cumulative relative frequency. As shown here, the results of group 1 is the larger side, while the results of group 3 is the smaller side. The accuracy of the predicted peak equivalent displacement is satisfactory for both modes. This figure shows the accuracy of the predicted peak displacement at level Z0. In this figure, the median value of the accuracy ratio is considered. As shown here, the results of group 1 is the larger side, while the results of group 3 is the smaller side. The difference of the accuracy ratio at frame Y1 and Y6 is not significant. It can be concluded that the predicted peak displacement at level Z0 is conservative. Next, this figure shows the accuracy of the predicted peak drift in the superstructure. As shown here, the results of group 1 is the smaller side, while the result of group 3 is the larger side. The predicted peak drift at the upper stories in column A3-B3 is unconservative, while the predicted peak drift at the lower stories in column A1-B1 is conservative. Therefore, the accuracy of the predicted peak drift in the superstructure depends on the pulse period. In this presentation, the accuracy of the updated mode adaptive bidirectional pushover analysis is investigated considering pulse-like ground motions. The results show that the updated procedure can predict the largest peak relative displacement at level Z0 with satisfactorily accurate. However, the peak story drift in the superstructure is unconservative in some cases. The influence of pulse period Tp on the accuracy of the updated procedure is limited. For more details, please check the following papers. This is the end of my presentation. Thank you very much.